Welcome to Physics with Mr. Brazil. We're looking at a force on a box on a ramp, and that force is horizontal. So we have a 55 kilogram box. It is pushed horizontally with a force of 440 newtons up a ramp 30 degrees. What is the acceleration of the box if the coefficient of friction is 0.015? So here's our setup on the left side. We got this force that's horizontal to the ground, not the ramp itself. And I made a dotted box that's just the exact same box. I'm going to put a dot where the force is at. And let's look at our forces, our real forces. So we have the normal force, the force of the box on the ramp. We have the weight of the box, Fg, which is a resultant force. So I'm going to make that red. And then we have the friction force that's going to the left. And noting left and right, the ramp itself, I make that the x-axis. Fn is in the y direction. So that means our force, the applied force is a little off to the side, but it's a real force and it's a resultant force. So that means both weight and force have components. So let's tackle the weight because most folks know that. I call this Fgy because it's in the y direction. Some teachers will call it F perpendicular. The other component force for weight, which will make a right angle here, is Fgx, and that is parallel to the ramp, so that's in the x direction. Now let's take a look at the actual applied force. It will have a component vector that's I'm going to call Fx because it's in line with the friction and the ramp. And then we have Fy, which is also in line in the y direction with the normal and Fgy. And notice that theta is right here, so that means Fx is going to be the adjacent cosine, while Fy will be the sine. And then, as folks have probably done in practice ramp problems, Fgy, or perpendicular, is the cosine, because it's the adjacent, while the Fgx will be the sine component. Okay, so let's put this math together. I took the picture, brought it up to the next slide. And we're going to find the net force in the y direction. Fn is positive because it's upward, and Fgy and Fy are negative. So I'm going to solve for these, meaning I'm going to put their actual trig function. So mg is the weight, so it's going to be mg cosine, do the adjacent. And the force itself in the Fy direction will be F sine theta. So now that we have Fn, we can tackle anything with friction. So we're going to have to look at our net force in the x direction. So minus F friction, minus Fgx, because it's going to the left, so those two are going left, and going positive is Fx. Now let's put our trig functions, especially for the x direction, so as not to get too confused. We're going to see Fgx is mg sine theta, and the force applied time cosine for Fx. Let's tackle Fn. And again, slow down these videos, pause it so you can see the math, and practice this math. Write it down on paper. Don't just watch the video, write it down on paper. So now I'm going to take Fn from up here and bring it down for Fn. So mg cosine theta plus F sine theta. Notice that there's the minus mu on the outside. We're going to have to distribute that. I'm going to go to the next slide on this. Same equation. Now let's distribute the negative mu to each one. Fn, not Fn, but F sine theta. And then we have our right side just left the same. I'm going to rearrange this. I'm going to combine all the things with mg together, and I'm going to combine everything with the force together, the applied force, and I'm going to factor it out. So check this out. I'm going to take, since this is a minus mg and a minus mg, I'm going to factor out minus mg and make these all positive. Keep mu with cosine. I'm going to factor out the force, and I'm keeping all the signs with the original trig function. Again, mu sine theta. I'm now going to rearrange, get this m and put it underneath so that a is by itself. Now, notice that I did not use any numbers. Always move the variables first. This way you can organize your thoughts. Now you can apply your math. You can take your 55 kilograms, 440 newtons, 30 degrees, and the 0.015 and plug them in the right place in the correct order. At least your math will be organized correctly. Now it's a matter of punching it in the calculator. Okay, now I recommend using units unless this is like an AP test and you have to put units at the end, but everybody should be applying units. That way you can see things cancel out. You should get 1.8 meters per second squared. Now, keep practicing physics every day, especially if you're a physics or an engineering major. High school students, I know you don't like to practice every day, but at least do it every other day. Enjoy practicing physics and have a great day. Bye.